So the code we've just written works, and it seemed fairly simple. But I want to give you a warning because there's a potential trap here that is very easy to fall into. Let's look again at the equality operator in the food base class. There it is. I've implemented it by calling the static objects.equals method. Now, one thing that's very tempting to do is to say you want this method to be efficient. Let's just put the equality logic directly in it, something like this. I've commented out my original objects.equals call, and it all looks great. The logic is correct, and by doing this you've avoided the overhead of a method call. And in fact, if you look around the internet, you'll find a lot of blogs that tell you to implement the equality operator like this. At the time of recording this course, even some of Microsoft's own MSDN documentation contains samples that do this. And I really hope that Microsoft fixed that documentation at some point, because doing it this way is a mistake. And I can prove it's a mistake very easily by just running the code again with our new equality operator code. Look at that. Everything has come out equal to everything else. Baked apple equal to stewed apple. Uncooked apple equal to stewed apple. These results are crazy. But the logic looked so good when we wrote it. What's gone wrong? Let's do some debugging. I'll put a breakpoint at our call to compare stewed apple with baked apple and run in the debugger to there. And I'll also put breakpoints inside both of the equality operators. And continue the code. And we hit the breakpoint in the equality operator for food, and the locals window shows us that the two parameters are stewed apple and baked apple, as we'd expect. But look, these are both cooked food instances. We are in the equality operator for the base class food, and we're about to hit the actual equality check. And here's the thing, because we are in the food base class, this check only compares the base fields. The food base class has no idea what other classes might derive from it. It doesn't know that the cooked food class exists. So there's no way this method can possibly know about the cooking method field in cooked food. But that cooking method field is what distinguishes apple, baked apple and stewed apple. That field doesn't get checked, and that's why all these variants of apple come out as equal. So how did we end up in the base class operator comparing derived class instances? The problem arises from the fact that, as we discussed in the earlier module about the C# equality operator, operators are static and therefore not virtual. If we look up the call stack at the display whether equal method, this is what calls the equality operator. But this method takes food parameters. It has to, so that it can take any food object. And because operators are never virtual, the compiler has to determine at compile time which version of the operator to call. As far as the compiler is concerned, these food1 and food2 variables are of type food, so it's going to call the food version of the operator, which of course has no idea how to compare cooked food instances. Let's stop the debugger. This is a truly horrible bug. It showed up immediately in this sample because I deliberately constructed the sample in a way that I knew would show up the bug very quickly. But usually it's more elusive. More often than not, you'll write code like this. I've pasted in code that calls the equality operator in the main method, and in this method the compiler knows that the two variables are of type cooked food, so it'll know to call the cooked food equality operator, and everything will work. So this is a bug that, if you're unlucky, can easily pass through all your testing without you noticing it. and then it can blow up after your app has gone live. You don't want it.